Hey guys, today I'm going to be recording my interview coding practice as I have a couple of interviews set up with a couple of companies in the city, so in New York City, and basically I thought this would be the best way to kind of force myself to practice almost in a quasi interview setting. So being able to use Google Docs, being able to code without uh, the help of an IDE or code editor. And so basically what I'm going to be doing is I'm going to be using the same kind of time parameters as I would in a normal interview. So I've read in a lot of this technical interview prep documentation that you want to be able to solve two medium LeetCode questions um, in 35 minutes. So that gives you roughly 17 and a half minutes or 17 minutes and 30 seconds per question. So what I'm going to be doing is just for the session, I'm not sure how long it's going to be, maybe an hour, 20, hour, 30 minutes for this first one. Just going to go through these questions and just go through them under 17 minutes and 30 seconds. If I can't solve something within that time frame, I'm going to basically just move on to the next question and then review it later. So let's get started. So what I did first was basically I just went to LeetCode and I filtered out the questions to Facebook and Medium. So I'm going to do the first one. So our first one is going to be LeetCode number 29, which is divide two integers. So let's try to do that. Two integers. And let me set a timer. I'll be right back. So with this timer, I'm basically gonna just honor system. I'll show my phone, but only 17 and a half minutes per question. So let me get that set up right now. 17 minutes, 30 seconds. Okay, so let's get our first one started. Divide two integers. And you might be asking like why I am using the Google Documents thing. Again, is just make sure that I don't rely on a code editor or autocomplete functionality of a code editor to be able to solve these problems. The reason they recommend that you're able to solve it on a whiteboard or by writing it down on paper is because it really forces you to really know the fundamentals in order to solve these questions. Okay, so let me just expand this. Okay. Oh, and I will be writing in Python, so all these questions will be in Python. Given two integers, dividend and divisor, divide two integers without using multiplication, division, and mod operator. Return the quotient after dividing dividend by divisor. The integer division should truncate 0. Okay, let me write that down. The integer division should truncate toward 0. So that possibly means rounding down, which means losing its fractional part. Losing its fractional part. For example, truncate equals or rounds down to 8. Truncate rounds down to -2. But okay, that's rounding up. Okay, so if you take the dividend, divide that by 3, you should get 3.333, and then you want to truncate it down to 3. All right. So the little bit notes are both dividend divisor will be 32-bit signed integers. Okay. Divisor will never be 0. That's good to know. We don't have to deal with those type of errors. Assume we're dealing with an environment which could only store integers within the 32-bit signed integer range. For the purpose of this problem, assume that your function returns 2 to the 31st power minus 1 when the division results overflows. Okay. So that last note makes me think that a couple of use cases you should consider are these very large numbers that go past this 2 to the 31st power minus 1 range. So that's good to know when you're designing your algorithm. For this, given that they want you to basically divide two integers without using multiplication, division, or a mod operator, they probably want you to do like a bitwise operator, which I do not have the most familiarity with, but I know that's something you could do with, especially with signs, moving those binary numbers a certain way. Again, don't have a good intuitive sense of that right now, but let's see if I can find that, like how to use that way or do a different way. So I can't use multiplication. Division or mod operator. Okay, so I can use subtraction, so that should be helpful. So I could probably do some while loops over the subtraction. Another thing, you want to take note of is having that range between, remember, being -2 to the 31st power and 2 to the 31st power minus 1. So we need a base case that returns whatever result, or make sure it isn't over that base case. Excuse me. Okay, so yeah, what I'm going to be doing on a high level is for dividend and divisor, what I want to do is dividend is greater than divisor. While true. If so, while true. While true, subtract divisor and keep track of about those times you are able to do that. Update dividend until condition is false. If false, return count. And then of course you gotta like make sure that you're taking into consideration signs. Okay. Oh, sorry guys. Oh, maybe some more water. Okay, I think this is a simple brute force solution again. Once I solve this, which I believe my hypothesis is that this will be O(n) time for the looping, and then truncate, we shouldn't have to deal with that because what we could do is do some type of number proximity like for the remainder. So when we get to the remainder, we'll see like what we do there. But for the time, we are only really, I think it's gonna be constant because constant space because we are not creating any new data structure from this and above integers. So for the most part, I'm not using anything. So let's try to code this out. And again, for this return count at the end, we gotta make sure it's in that range between -2 30 to the 31st power and 2 to the 31st power minus 1. Okay, so again. Let's look at this. So I'm gonna have divisor count helper. So we call that. It's gonna be scoped to a variable. Excuse me. Then return count. Alright. I'm gonna put in there the dividend, the divisor, and the count, which I think at the beginning we're just going to have be 0. Okay, and the reason I'm just doing this is make it a little bit cleaner. So okay, divisor count helper, and then the dividend divisor, and then we have the count, which we will be returning. Excuse me. So we can have like a little recursive call here, which just makes it kind of a little bit simpler to use. So we can have a base case here. What is if yeah? So if divisor return count. Okay. So from there, then we can actually like start doing our recursive calls. So from this, what you want to do is if it's not, so then you have else. So divisor is smaller than dividend. What you want to do is you know what? Maybe we don't need this recursive call. Maybe we just do this iteratively. So while dividend is greater than divisor, dividend minus divisor count plus 1. Okay. So return count here count is smaller than, so I've got to import math now too. Import math. If count is less than math.how to 31 minus 1, and count is greater than math.how. Oh, we don't even need the math.how, sorry. So well, we can just do the things. Count is greater than -2 times 31. Else okay, so actually we don't need this one. We can just do okay, so once we have that count, so 10, so that does it 3 times. So that actually kind of deals with the truncation. Yeah, so then I can just return count. So, okay, so again, yeah, so on time, what we're doing is just a helper function, passing it down here, just doing a while loop, which this is the O and M time right here. Okay, and then we just add, and then so we don't deal with the truncation as we're doing the counting, so that's good. One thing I forgot to do is in terms of negative or positive numbers. So what you could do there do an absolute, and then keep track of the sign. Okay, that deals with it. Test cases, I would have probably one where the number's just like really small, so like 1 and like 1. So test cases, return new test cases, dividend equals 1, divisor equals 1. Okay, let's see if this works in this code. So I got 25 seconds left. Let's check this out. Okay. Second. so that's the first question that got done. I passed some test, but it seems that with the big numbers that it's going to fail, so that's good to know. I can essentially learn about bitwise operators for these types of problems, especially when you're forced to do them without like these restrictions, specifically the can't use multiplication division or mod operator. Let's see how much tests I passed. I only passed 4, so there's obviously a better way to do this, but this was just my first pass route. So let's go to the next one. 1 second. Okay, back there. Let's go back. So we tried that one, so I'm just going to submit so that can fail, and that really failed. So we tried that one. Now let's go to the next one, which is 523. Okay. Let me reset the timer. Reset the timer right now. Okay, so this is 523 continuous subarray sum. I almost spelled continuous wrong. 1 second. Again, good thing with spell check. And edit distance too. Okay. Okay, so for this problem, given a list of non-negative, okay, that's a really big hint, non-negative. And a target integer k, target integer k that is sums up to n times k, where n is also an integer. Okay, let's look at some of these examples. Okay, so we have a list of 23, 2, 4, 6, 7. One of the questions I would just ask the interviewer immediately is the list, or in this case, the nums array, already sorted. Okay, 23, 2, 4, 5, 6, 7, k equals 6. Explanation, because 2 and 4 is a continuous array of size 2, that sums up 6. Okay, so if we have 6 here, 2 and 4, that would not be continuous, but you have 1. Okay, I'm having a little confusing with this because the second example, 23, 2, 6, 4, 7, and a k of 6, the output is true, and it's saying because this list is a continuous subarray of size 5, it sums up to 42. So, let's see. Given a list of non-negative numbers and a target integer k, write a function to check if the array has a continuous subarray size of at least 2 that sums up to a multiple of k. Okay, so subarray has to be at least 2. That sums up to be a multiple of k. Okay. Okay, and it has to be continuous too, so I'm assuming the elements have to be adjacent. So let's say, for example, yeah, the 2 and 4. Yeah, so right here, this first example was successful because 2 plus 4 equals 6. So n is greater than or equal to size 2. This one, even though 2 and 4 are in this array, they're not adjacent, so they're not considered a possible solution. But if you add all of these up, then they do equal 42, and they're greater than the size of 42. So I think the big thing here for me to question is how big, yeah, how big can the multiples of k get, and how does that like affect your answer? Because if you pre-compute all those values up to a certain point, and I guess in this point, sign 32-bit integer, that makes it easier to like look it up if it's already computed. But in this case, is there a way to yeah, we'll write that down. Is there a way to check as you go? So essentially, an iterative calculation of multiples of k. Also, how are we going to be doing the iteration through this list? What makes the most sense? Because you could do like a brute force way, but that would be O(n) squared. You could do 2 pointers. Again, I think you might run into like O of n squared, the quadratic time there. So how would this work with 2 pointers? So 2 pointers might be like, okay, we have 23, 2, and then does 6 divide into like that addition? No, then just go, okay. So I think the brute force way I can go is O(n) squared quadratic, and then summing range and seeing if it is divisible by k, depending on mod remainder difference equals 0. And I'm pretty sure this could be a greater way to do that. One way you could do that is possibly by sorting the list. I'm trying to see if that makes sense, because then you can just combine the thing. Check that out. But how would that work? So you need to divide the numbers. Okay, well, I'll just put this down. Potential idea to speed up brute force is to sort the array and use some sort of and use binary search possibly. And the way you could do that is if they don't add up like all the numbers. Oh, okay. All the numbers to the like that are smaller. Oh no, but then you want the adjacent, so that's how it would not work out. Unless you keep track of the original positions through like an additional list of indexes, which for that you would increase your space but reduce your overall time complexity. So I'm gonna write that down. Yeah, sort the array, so that'd be O of n log n time and O(n) space for additional list of arrays, list of indexes for array. Okay, def check array sum Okay. Oh yeah, sorry. So what I'm doing right here is just basically just doing a double for loop because it helps with like the continuous or adjacent like indexing to that range. So like basically what's going to happen is if we go through this example right here. So right here you're at 23, and then like that's index IDX. Then the next one is JDX, and then you're basically just looping over here continuously. So you're tracking like, hey, does the sum of um, 23 plus 2, 25, that divided by k, does that equal a result? If no, then you move JDX to the next one. Yep. So basically just move into the next one. So then you like you essentially sum up those and then check is it dividable by k and there's no remainder. No, then you go that one, then this one, then you go all the way back, and then you increment the IDX, and then you just repeat the process. So one thing to keep into consideration is within this double for loop, sorry, there's a little fly there. Within this double for loop, you also have to ask if there are any like heavy time computation operations you have to do. So let's just finish this out. And this starts out at IDX plus 1. And then you're just checking. Oh yeah. So this is where the additional thing you have to consider. Every time you create a slice of an array in Python, you're actually creating a new array. So that's an O and N operation. But for this, again, we're just doing brute force, so this might change it into O of n times 2n. So it's still like O of n squared plus n. So O of n squared in total. So with this, sliced equals nums idx jdx plus 1. So for this, you ask if sum is divisible by k equals 0, return true, and then else false. So let's check that out. So let's say I have this. So for 23 and 2, does that equal, that's index 0 and 1. So in this case, 1. So you include those two. Yeah, so 23, 2. So sum of sliced. Where did I check that out? Divisible by k, and then there's no remainder. Return true, else false. I think this is good. Check it out. Again, brute force solution. We will try to optimize that. Okay, and right here I'm just changing some like small little errors due to Google Docs. So with this, again, this is going to be O n squared time, and like technically since I'm creating a new array, I guess I could do, because it's a different length, even though it is that same array, n squared time O So with this, I'm not, the only thing I'm really creating is that slice right there, so I guess I could call that in for space. Alright. So let me just go for this code again. Yeah, you're basically quadratic time because of that double for loop. Let me just put this one right here. The reason I'm adding one to here is just because the second parameter on slicing. So on start, on stop, the stop index is not inclusive. So you want to make sure you capture everything you're trying to capture. Then from that slice thing, I'm just checking if the sum is dividable by k. Oh, and then like one thing I have to make sure if the size is greater than 2. Which should be the case because, yeah, that's a kind of built-in. One thing I do want to check for this is if nums is length of nums is less than 2, return false. So maybe I can just make this easy. Okay, let me do print sliced. Okay, so that's the end of number 2. I think they passed some tests. Let's see which ones. No. Okay, well, it's a good learning experience, so let me set that there. And go back to the next one. As you can see, like a couple of my issues that I'm working on currently with is essentially these like little one-off errors, making sure I create like more elegant solutions. And why can't I go back? I guess just to go back here, go back to Facebook. And then do Medium. Oh. And now we'll go to the next one, next permutation. So let's start up the little clock. Oh. Here you go. So here we go. 31, next permutation. Implement next permutation, which arranges numbers into lexicography next graded permutation of numbers. If such arrangements are not possible, it must rearrange it as the lowest possible order. Lowest possible order, like that. The replacement must be in place and use, okay, in place, very big hint. In place. So when I hear in place, I usually think swapping. Like a very good technique to learn. Basically, yeah, if I were to write an article on like how to like get good at these like practice ones, I'm not saying I'm perfect, but it's to know how to like swap things in place with an array, which is essentially just this simple one-liner in Python. And let me see if I can actually. So it's essentially just doing this. So whatever your array is called, the first index, the second, sorry, second index you want to fix, and then equal sign, and then you just reverse the order. And this reverses everything in place. Okay, with this, next one, here's some examples. inputs in the left-hand column and its corresponding outputs in the right-hand column. Okay. Implement next permutation, which rearranges the numbers in the lexicon coding the next greater permutation of numbers. Such arrangement is not possible. It must rearrange it as the lowest possible order, sorted in ascending order. Okay, so implement next permutation, which rearranges numbers into the lexicographically next greater permutation numbers. If such arrangement is not possible, it must rearrange it as the lowest possible order, i.e. sorted in ascending order. Okay, I can kind of see that. So like if this is already like ordered like here and here, then you do the next best thing is to change those permutations. Here are some examples, inputs in the left-hand column and corresponding. Okay, so your normal permutations, you do it two ways. The ones like kind of with the backtracking route, or you swap, then you do a recursive call, then unswap. I think you do something similar with logic. You might have to make sure anything is already in ascending order already. And with that, I'm just going to take a little quick pause and go to the bathroom. Be back real quick. Alright, thanks for waiting. Let me restart this timer. So we already spent 3 minutes here, so going to restart it. Alright, so with next permutations, if you think about how you normally do permutations, again, like you do like one of two ways, I think. One way is just looping through a range and then doing a while loop and then like switching the order of the indexes. And the other one, like I was mentioned, is like kind of recursive backtracking. You swap, do a recursive call, and then you unswap. With this, I think I'm a little confused about, and I would ask the interviewer is to confirm if something's already in ascending order, is to basically just do a permutation where the subsequent two numbers, they just like switch off. So for example, let's say you had this one right here. So let's say you had 1, 1, 1, 1, 1, 2, 1, that. Like, what would you want as the answer, right? So I see like right here, they basically have just swapped the second position with, second position with the third position element. So example. Loop code. So in this case, let me just make sure again I'm reading this right. implement next permutation, which rearranges the numbers into the lexicographically next greater permutation of numbers. So I don't know what this means. I would clarify this with the interviewer, like, obviously be like very humble about it. Like, what exactly do you mean by it? Lexicographically next greater permutation numbers. In that case, do you want everything in like pretty much the same order, but the next greatest element is like right here? So would this list change to this? Oh, sorry. 2, 5, and then everything else is the same. 1, 1, 1, 1, 2, 3, 4, 1. So essentially what I did here is I just swapped the second one. I swapped the second one for the 5. So I would ask the interviewer, him or her, like, does this make sense? Is this essentially what you want? And if I wanted to just implement a normal permutation function, I think I would just do the backtracking route. So swap, recursive call, unswap. So we would do that with indexing. So I think I'm going to do that and then try to add the rules as I go. So with this, index, right? Index. And again, I'm just using a helper, make things cleaner, and then I can add like whatever input parameters I want to. Um, probably get like a is in ascending order. Just because I think that's how you branch off, like how to like um, return these, like which function to use. So I'm just going to put this as a function we may implement. Who knows? So again, I don't have to return anything. I just have to call this helper function. So, no. Yep, so just having this helper function so it makes the coding a bit cleaner. I'm going to loop over in the implementation helper over a second uh, index called JDX. So I'm going to do it. And then let's just say we need a base case 2 before then. We call this recursive function. So let's see. If IDX equals 1. Okay. I'll just do the swap IDX JDX. And we swap them back. That was swapping back. Yeah, I think we're good. I think that helps us. So let's paste that in here. Let's get rid of this function. And then I fix all these errors right here. Dude, actually good. Yeah. Oh, because the particularly and it's also within the class. I have to make sure to include this class parameter here, and then we call these functions, add swap, self dot whatever the method name is. So let's go right here. So we got everything here now. Okay, so that's good catch. Okay, So I am getting some permutations. Maybe I don't have to do all of them either, because all I'm doing is swapping them and not keeping track of them. Interesting. So if I do this, switch this from JDX and IDX. Yep. Okay, about to run out of time for this one. I think we got 40 seconds left. The details. Only 2 passed. Okay, so I got to work out a little bit on these like permutations and the array problems, but let me just do the original one. See how many tests I did not get there. And yeah, I just think there's a fundamental misunderstanding on my part for this question, like knowing exactly what they want from the lexicographically next greater permutation of numbers. So I'm definitely look after this later. And yeah, just I'll approve like after I review what I've done. Okay, so with this one, it's about to end. So cancel, and now let's go to the next one. Okay. So this next one, and I think it'll be the final one for this little live stream, is going to be 211, add and search word data structure design. Oops. And let me start this right here. Add and search word data structure design. Okay, so just like kind of reading this sounds pretty much something I either watched or did before. So it might be using hash maps, dictionaries, like they mentioned in the title, and looking at this some classes too. So let's see what they have us do. Design a data structure that supports the following 2 operations: add word, search. Search word can search a literal word or logo expression string containing only letters, A to C, or dot A dot means it can represent any one letter. So if you add a word, bad, dad, mad, search, add, false. Oh, this is interesting because if you're just doing add word and then, oh, okay, I see why it's interesting. Like when you actually have like a regular expression, like, hey, do you have like these particular words? So you could use some type of edit distance. So I think easy is like for us is just going to create like a hash map for this add word. So add, oops, for add word. And then the other expression could like come in as like, hey, just like chop off like the punctuation marks and just look for like those 2 characters. So in this case, we would have bad, dad, mad in here, and if we just ignore that period and we like use some kind of added distance, like, hey, do we have any words close to this? And if we do, if it's like within however many dots, then true. So b dot dot. Let's say you use edit distance and then remove A and D, then yes, that's true. So the actual complicated part's going to be the search. I guess something you could do too is like add every permutation, like in the value part. So the key is actually the word, and then like the permutations are the values, like in an array list. So you have like an array of string permutations. The only deal there is if you use the permutation, that's n factorial time, which is one of the worst. So I think we're going to stick to some type of edit distance, because I think with edit distance you can get to, I believe, O m times n or O m plus n time. So really interesting problem. Yeah, so all I'm typing here in the Google Doc is second, clear. All I'm typing in is not hash map. All I'm typing in here is like for hash map, it's going to be like constant space. So not constant space, sorry, linear space, because the amount of like words that we help generate are going to be put into that dictionary. So with that, and then like search is constant time, so that's good. Okay, so for this, search is going to be some combination of edit distance. So yeah, I think it might actually be edit distance here. You know, a naive approach what we could do is just iterate for all the keys in a dictionary and see if that phrase is, like, check the length of like the searched word, and then like check if it ends or starts with like that particular word. The only thing you might have a problem with is, let's say you have like a word like dot a d dot. So like let's say you have a word like made. You can't use starts with, or you can't use ends with. You can use like this is in that. But like once, what happens if your string is like really big? So let's say you have like a 17 word letter, and then like index points 6 and 7 are A, D, and the rest of the outside are dots. How do you make sure that you check for that? And you might actually just be using like indexing there. And that might get really complicated, but I think because edit distance might take too long to set up, that might be the best way. So like using iterating through keys, and then verifying the indexes of characters in search uh, term through a loop. I'm guessing through a loop match um, match the same indexes of characters in Word. And then, I mean, just make it easy, because I don't know regular expression off the top of my head. It might just be easy to, yeah, so all these are lowercase, so all I have to do is do like one long string. Here, check this, this is here. So let's sort this out. Word dictionary. So what I'm going to do in Dunder and Knit, self.alphabet equals set A, B, C, D. E, F, G. I know I could use OR, but this is just going to be like simple. L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Anything I want else to initiate? No, I think I'm good there. Add word. Oh yeah, and then here I want to actually add the self.collection equals. So this could be my hash map. Dictionary terms. So this could just be your standard pattern of like verifying something's in a dictionary. If not, then like so don't. I think the only thing we're gonna do modifying if it's already there, just pass, or don't even do the conditional statement. And if it's not there, then basically initialize that and set it to true as the value. So with that, and one thing about doing later is iterating through the keys of the collection dictionary or hash map. So again, I'm using indexing based on this word. Now I'm setting it to true because all I care about is the keys, and then I check and make sure if that exists or not. Because I don't know the definition, so that's fine. And I don't think it matters for this question. So now I'm going to do the search. We got self, word. Then here I'm going to iterate through the collection. Well, that's going to be a eventual step. So for So yeah, again, I'm just like send this as a to-do, pass, or I can just like have like a print statement here. But I'm gonna iterate through this like once I figure out like what I need to search for, in this word that's coming in as input. And then like from this, it's just gonna return true or false. So let's find that out. And then our default's gonna be false. And then based on this like iteration, if anything's found in keys, then we'll return true. And then for this, we gotta verify if we have a complete word or not. Okay. So for this word, so how do I keep track of indexes and the letters too? So for this, the word, I mean, something you can just simply can do is so this like simple is if word in self.collection return true, and then this else statement is like we'll reiterate. So that's like our simple base case. this. I can do for, okay. So if that's not the case, we'll do it for the keys. What I want to do is okay, so if we're doing this, okay, so then here in the word, this is okay, let's see this. Okay, so basically what I did here overall is really easy for adding word. If it's not in the dictionary, add it to the dictionary, set to true. for the search, what I did, hey, if word is in self collection, boom, you have exact match, true. Else, and then that's where we have to get into these like periods and regit kind of thing like that. So what I did there was I iterate through like each one of the dictionary keys. A simple way, base case to break out of it is if the length of the key does not equal the length of a word, then you can just move on to the next one. Um, and then I keep track of the length of the key and the length of the match, and then I iterate through the characters in the word by using the index. So that naturally assumes that the word and the key are the same length. So if the current character is not in the set of alphabet letters, then you just add one because you assume it is period. Else, if the character and the key, like at index 0, 1, 2, 3, 4 to the end of the length of the array, are the same character, then you add +1. And then if you basically have like an exact match, you return true. If not, then you just keep on iterating through those keys till the end. And then if those values don't match, then you return false. So you're basically just trying to find true first, and that doesn't happen, then you return false. So let's see if that works. And I've got to change some of the things. See, do a quick test and see what happens here. And then in the next stream, don't worry, I'll try to be a little bit more talkative in my thought process. I know sometimes I got lost in thought, so this is something I definitely improve on. And yeah, this was a very fun first stream, and hopefully I can do a little bit more. Well, not necessarily stream, but like going through this coding process. I really like kind of recording what I've been able to do, and hopefully this gets better as time goes on, and I can crush my interviews too. So let me just fix this real quickly. Perfect. Let's file them here. Okay, let's run this code. Oh, all right, something must have gone awry here. So let's see what the issue is. Oh, I see what it is. It's like in Google Docs, it's your quotation marks. They're different than the ones you use for programming. So let's make sure that doesn't occur anywhere else. All right. Okay, we got these issues with the tabs. Okay. Let's fix everything here. Okay, let's see, everything else looks okay to me. I set this else statement. Okay, I think everything's lined up now. Okay, where am I not doing this right? Okay. Ah, nice catch. Let's see if we have any more gotchas. All right, that final little R right there. sorry. Interesting. Oh. Oh, it did accept it. Nice. Okay. Accepted this one test. Let's see if it does anything else. You might get some extra characters that, besides periods, that don't make sense. Um, and it seems like mine's going slow, so I could have probably improved like what's happening in here. I think I have this as oh yeah, definitely have this as n squared or quadratic time because I use two for loops and to do that counting for search. So let's see what the details are. Oh, so I passed nearly all of them, so I need to look back at this. But yeah, I probably would have used something a little bit smarter on the search thing, but that's the kind of brute force I thought of when I first did that. But anyways, thank you guys. I actually have to do a mock interview with my friend right now, but thank you. If you find any value on this stream, please hit like or subscribe. And yeah, just thanks for watching. I'm gonna get better at these, and you can do better at all this stuff by just practicing. So I'm definitely a lot better than a couple months ago, a couple weeks ago. So this consistent practice is gonna make you better for the interviews, and hopefully for me too. And I keep you updated on like what happens there too. So thank you guys. Peace.